Hello, welcome everyone to episode 18 of the RS Nano development stream. Hello guys, hello Wenderson, hello Endefnal, hello Sergio, hello Pais, hello, hey Nano fam, how are you? How was your week? It's Tuesday again. Time to write some Rust code. Yeah, we had another open developer meeting today on Twitter. Quite interesting. We had a couple of interesting discussions about the current state of the beta, or the current state. And yeah, performance optimizations and performance problems that we need to solve. So if you haven't listened to the dev meeting, go to Twitter and you can re-listen it there. And Ifnal says, hey Nano fam. Alright, so I put you on the wheel already. So on the wheel is Sergio, Andifnal, Wenderson, and Pais. So if you want to be on the spinner wheel and take part in the giveaway, just post your Nano address in chat. So last stream we worked on the message deserializer, and we made it. We would try to make it async. So hi Bob, I think you are in my address book already. Yep. So you're on the wheel too. Here guys, you can see it, the spinner wheel. And today we are going to continue our work with the message deserializer. Or maybe not, who knows. I made a couple of notes of things I would like to refactor and would like to work on. And maybe you guys are interested in working on different stuff, so you can actually decide what we do. And Ifnal says, today we have it kind of jazzy. Yeah, I'm trying different things. What do you guys think? Is jazzy good? Do you like it? Where are my notes? Yeah, so I made, and I just move that window here so you can see it. Yeah, so I have some notes of stuff that I would like to work on, and if not says works for me, that's good. So yeah, last stream we said we have to return correct error codes in the message deserializer. Yeah, this thing, I'm going to discuss this. Now, what I mean by A-frame architecture for message deserializer, we have to use our new async message deserializer and delete the old one, of course. And the last two bullet points, so convert message to enum, that's basically what Piotr said, even in this developer meeting, where he said he had a look at C++, what was the name, variants? So that we don't have to heap allocate every message. And that's actually, I wanted to do the same in Rust too, where I don't want to heap allocate messages, and I want to use an enum so that we know the size of a message and we don't have to heap allocate. And if now says, so no stupid buffer stream? I don't know if all of you in chat are in favor, I don't know. No, not even then. No, not even then. Oh, LF is here, so let's put you on the wheel. There you go. So okay, where do we start? Maybe let's just bring up, yeah, so the message deserializer. We worked on making the message deserializer async. And the plus is ready to rig the game. Yeah, so the game, if you don't know that yet, the game is rigged. The game is definitely rigged. So don't expect a fair payout. Yeah. So maybe let's start with what I mean with the A-frame architecture for message deserializer. So this is something I thought about yesterday. And let's draw a sketch. So this is the sketch from last stream. Why does it look different? Okay, now it looks correct. So this is the sketch from last stream. And let's move that to the side. And let's discuss something that I'm... Oh, and let's start the Bitcoin timer. We pay out 1 nano for every Bitcoin block. So basically for every 10 minutes. So 10 minutes for a Bitcoin block. And then we immediately create nano blocks. Hey, Johnny. Hello. Johnny, do you want to participate in the giveaway? Then post your nano address. Or maybe you are in my address book. No. So if you want to take part, post your nano address and you can win 1 nano for every Bitcoin block every 10 minutes. All right. So, oh yeah, no. Back to the diagram. I wanted to show what bothers me with the way messages are currently implemented and how the message deserializer is currently implemented and how we can improve on that. So let's draw the current design. So currently we have message as a trait. And for all of you non-Rust guys, a trait is an interface. Like an interface. So we have the message trait, and then we have all of those message types that the node can send and receive. For example, confirm ACK, confirm rec. Let's just put 2 or 3 there as an example. Rec, confirm ACK, and what else? Let's put a 3rd one there. Another message that we have is publish. Is publish the name? I don't even remember. So we have different messages. And with the different payloads, different data in them, and they all implement the message trait. And when we work with messages, we use a box din message everywhere. So that means a heap allocated fat pointer, heap allocation for the messages. And as Piotr pointed out in today's dev meeting, heap allocations for messages is not a good idea. It is quite slow, and we should not do that. Oh, Johnny posted his nano address. Let's add him to the address book. Address book. So there you go, and let's put you on the wheel. All right. So 7 minutes. In 7 minutes, guys, we give away 1 nano. So that's the current design. And there are a couple of things that I don't like. So for example, so the first thing is that we are forced to heap allocate because we are working with a trait here and we don't know the size of the type. And the second thing that I don't like about this design is that a message... Oh, that was wrong. A message has a message header. And the message header contains information about the message, like the type, the payload size, and flags, and a couple of things. And currently, it is like that. So the message has the message header, and the message trait, it has a function for serialization, so serialize, which basically it turns the message into bytes, and it has a deserialize method to you give it a byte stream, a couple of bytes, and it creates a message out of it. And it isn't that simple. It is a bit more complicated. So, you know, guys, what is the best metric for code quality? You know, what's the best metric for code quality? It is what the fucks per minute in a code review. Do you know that comic with the what the fucks per minute? And I had a big what the fuck moment when I ported this to Rust, because I thought serialize would take the message and turn it into bytes, and I thought deserialize would take the bytes and turn it into a message, and that is not the case. So what serialize does is it, let me just add it here as a text. So, and maybe a different color. So what serialize does is it serializes, oh my god, serializes, is that how it's written? It serializes the whole message. All right. So serialize here, it serializes the whole message. And so of course you think, yeah, deserializes the whole message, but that's not the case. So deserialize, it deserializes only the payload of the message. So that's something that I don't like at all. So deserialize and serialize, they don't match. They don't match. And as a matter of fact, deserialize, it has to take the header as an argument. So we have to deserialize the header first, and then we have to pass the header into the deserialize method, and then deserialize only deserializes the payload, and it just takes the header as it is, and then it returns the message. And that's a what the fuck for me. It's really confusing. So what do you guys think? So Andufnal says, sounds confusing, a fine candidate for a what the fuck moment. Yeah, so when I ported that to Rust, I had a what the fuck moment there. LFLF says, deserialize with arguments? That's weird. Yeah, so that was exactly my thinking. I thought that this is weird, and I made a note that I want to change this when I have time in the future. And my plan is to change it into the following way. So this is the old design. So now let's start a new sketch here. So I don't want to be a message to be a trait. I want a message to be an enum. So let's draw that here. So let's say, let's say, oh, why can't I type? Yeah, enum. So message should be an enum with all the variants, and it still should have a message header. Oh, do you guys see that? Let me see. Yeah, so because my camera is in the way, let me move that more to the side. So it should still have a message header, and then it should have, no, sorry, message is not an enum. Sorry guys. Message is just a struct, and message should have a payload, and payload is the enum. And with this design, payload would have a deserialize method, and it would just deserialize the payload, and payload would have serialize, and it would just serialize the payload. And this would be like people expected, like that deserialize and serialize would match. And because payload would be an enum, the size of a message would always be known, and we could stack allocate it. And yeah, no heap allocations, a lot faster. And maybe we could even, like Colin talked about this today in the dev meeting, a zero allocation, or how did you call it? Zero allocation. So where a message would be just a few into a byte buffer. Even that we could implement. But I don't want to get too fancy here. So my initial idea is to move from this trait with this weird serialized deserialized behavior into into a message that has a payload, and it's an enum, and serialized and deserialized just behave the way we expect. So maybe, guys, if you're interested in this, maybe we can work on this on stream. I'm not sure yet, so it's just an idea that I want to work on. So that's one idea that I want to work on, and the other idea I would like to work on has to do with message deserialization. It's time for the Nano giveaway. Oh, where is the wheel? Let's go. And let's restart the timer in between. Congratulations, Sergio. You get the first Nano. Send one Nano to Sergio. All right. Yeah, congrats. And Sergio says thanks. All right. So the new time is running. Okay. So let's get back to the deserialization. So the other thing. So currently we have the message deserializer class or struct, and deserializer. And it works with a trait that we introduced in the last stream, and we called the trait buffer reader. And buffer reader is async. So we use that. Maybe I write it in there, async. It's an async trait. And it has, what does it have? I think the read function. Oh, Colin wrote something in chat. Colin says, the reason deserialize is weird because we don't know the concrete type of the message. Yeah, that's right. Publish, vote, etc. until we've deserialized the header, which contains the message type. Yeah, that is correct. And when I ported more of the code, I understood. So in the beginning, it was just a big what the fuck moment. But later on, I saw that was the reason, because, yeah, we first receive the message header, and the message header tells us which type of message it is, and only then we can call the correct deserialize functions. And I want to, of course, we have to keep it that way. We can't change that really. But what bothered me was just the mismatch of behavior in the serialize and deserialize function, because they appear in the same class, and to someone who doesn't know the source code well, I think people would just expect that serialize and deserialize would match. And to find out that they don't match is just confusing. And that's why I would like to change it into that design where deserialize and serialize would match on the payload level, and also serialize and deserialize. Serialize and deserialize would match on the message header level. So that's okay. So that's currently already like that. So message header has a serialize and deserialize, and those functions match. So what I want to do is I want to move that to the payload enum. Yeah. But back to the yeah, but of course we have to keep it in that way. We have to read the header first, and we have to deserialize the header. Then we have to act on the message type of the header and call the correct deserializer of the payload. Yeah. So in the deserializer, so last stream we introduced the async trait buffer reader, and this has a function, I think we called it read, and we can just pass it the number of bytes that we want to read, and then it takes those bytes and it calls the correct deserialization functions. And what bothers me with this design is that it is async, and we are just forcing now everyone who wants to use our message deserializer code to have an async runtime. And I want to make the code reusable, and I want to make it easily testable. And by just enforcing an async runtime on the users, I think that's not a good idea. So I want to refactor this a little bit into the A-frame architecture, and I've talked about A-frame architecture in past streams. It's a very, very simple architecture where we divide our code into 3 parts. We have the logic part, which does not use infrastructure. It's just pure logic, like functional programming. And we have on the other side the infrastructure part, which does, for example, network communication, talks to the disk, like reading from the disk, or to the system clock, stuff like that. So everything that is outside of our program. And on top we have the application part, and application is just a glue layer which connects the infrastructure and the logic part. And logic and infrastructure never talk to each other directly. It's always through the application layer. And I think this is a very simple and very neat design that we can use with the message deserialization, because the buffer reader is basically infrastructure, because we use that to read from the network. So let me add a text here. So this is infrastructure. This is infrastructure. And the message deserializer is currently 2 things in one. It is application, because it talks to infrastructure. Oh, I want to move that here. So this is currently application, and it is logic. It is both, because it talks to infrastructure and it has the deserialization logic in it. And I want to split this up so that it matches this design. So how would that look? It would, let's move that to the side. So that would look like this. Nano ETH says, love this Excalibur app you're using. Yeah, I encountered it by watching Primeagen, the Primetime. Do you know this streamer? I love him. He's a developer streamer, very famous, the Primeagen. And he used that, and I liked it so much that I'm using it myself now. Oh, Nano ETH, are you on the spinner wheel? Are you on the spinner wheel? Are you in my address book? Yeah, let's put you there. Okay, so this would look like that. So we would have, and with the names, I'm not sure about the names yet. So on the application level, let's call it async message deserializer. And this would be the application layer. And it would use, I don't know how to call it. Let's call it message deserializer. Serializer. The name, the R is Nanogen. So this would use the message deserializer, which would be the logic part. So that, and I'm going to explain what this means shortly. And it would talk to, let me think. It would talk to our buffer reader. And that would be the infrastructure part. Like that. And so the only difference here is this new struct message deserializer, and what it would look like, so it would just take byte slices. So this would have a deserialize function, deserialize, and it would just get the header, because yeah, we need the header, so we have to deserialize the header first, of course. It would get the header, and it would get a byte array, byte slice. And with this setup, let's move that to the side. So with this setup here, okay, let's give away one more nano quickly. Jean says, hello, I am already in... Oh, so okay, this doesn't count, guys, this doesn't count. So whatever's on the spinner wheel now doesn't count, because I have to add Jean. Is it pronounced Jean? So, sorry, whoever wins this, it doesn't count, it doesn't count, it doesn't count. Sorry. Alright, double L. Okay, this one counts. This one counts. LF. Congratulations to winning one nano. Successfully sent. Yeah. All right. And let's restart. So let's wait for another Bitcoin block. 10 long minutes. 10 long minutes of waiting. Thank you, says LFLF. So where was I? Yeah, so message deserializer. Message deserializer. So the logic part of message deserializer would receive the header, because that is the first thing that this thing, the async message deserializer, has to call. Of course, we have to deserialize the header first. And then it would just receive a byte array, a byte slice. And then the message deserializer could deserialize those bytes, and that would be completely free of infrastructure. Yes. This would be completely free of infrastructure. It would just receive a byte slice to deserialize. And this would be the thing reading from the network, and this would be the thing that combines the both. And we could write our unit tests all against the logic part very easily. And let's say someone wants to reuse our code, wants to reuse the RS Nano libraries, and he does not want to use async, then he could just, he or she could easily just use this message deserializer, which does not depend on async. So that's also something I would like to refactor. So Stream, what do you think? What should we work on? So maybe you can think about that, and we have a look at the code. And because we don't use our new message deserializer right now, but I want to do this refactoring on stream, and I also would like to do this refactoring on stream. Okie dokie. Yeah, let's go to the code. And I'm not sure where we left, really. I think, so we have now two classes, two structs. We have message deserializer v2, which is the async. Let's rename it to async message deserializer, because that's a better name than v2. So we have the async message deserializer. And we don't use it yet. Am I right? No, we don't. We don't use that yet. And we have... So here we have all of the deserialization code in there. Here, deserialize, confirm request, so all of that. And when we scroll down, then we have the read function, and that is the entry point. So read returns a result option. Oh yeah, I also wanted to get rid of the option. And I also wanted to, oh, let me add this to my notes. I also want to get rid of this status, parse status field. So I think parse status as a field doesn't make any sense. So let's add that to my to-do list. So we want to remove parse status field from async message deserializer. Yeah. And received header. All right. And this is the old message deserializer. And let's find the usages of... Oh, there's more usages here. So we have a usage in channel in proc. And we have a usage in channel TCP channels. And we have a usage in TCP server. Let's start at the top. Let's have a look at channel in proc. Does this look better? No, it doesn't look better. Let's close it. So channel in proc. So channel in proc is a channel. So channel is an abstraction in Nano. It is basically, yeah, a channel for talking to other nodes. And it is TCP, and in the past it was UDP or TCP, but UDP support was removed from Nano a while ago, and currently we only have TCP channels, but maybe in the future we will have quick channels, or who knows what other types of channels. So let's search for message deserializer. Oh. Here we have send buffer impl. Send buffer impl uses message deserializer. Oh, and this is the only usage.